Is that me?
Hello, David.
Mark, you live in the Bay Area, right?
I'm sorry, I didn't catch that. What?
You live in the Bay Area.
Yes.
Was that you a few nights ago at the Los Gatos coffee shop, listening to this guy playing country kind of like music?
Uh, I was I at a Los Gatos coffee shop? I might have been. I don't know for sure. I don't remember. Uh,
Okay.
I know over this last weekend I wasn't even in town, so it wouldn't have been then.
Yeah, no, I'm talking about probably like 3, 4 weeks ago.
Oh, okay. Yeah, probably. So do you think you saw me there?
I saw somebody who looked a lot like you, but it was kind of dim atmosphere, and I was in there for just a few minutes to grab coffee. I wasn't sure if it's you or not, and I didn't want to bother
Okay.
everybody if they were playing music.
Oh, okay. Yeah, it may have been. Actually, if it's the Los Gatos Roasting Company,
Yes.
I go there sometimes on Fridays or Saturdays because I like hearing the music there.
Oh, okay. So it may have been you. Yeah, yeah, same one. Okay. I really will give everybody maybe a minute more to join us.
Okay.
Let's see how much we accomplished today.
Is today going to be about test or about the SIPI?
We the plan is to do test again. So previous 2 weeks we actually switched topics due to availability of folks. So we covered test last week, and we covered test again this week. Um, there was a very interesting presentation that Bala from Siemens gave us. We actually covered that in, I think, 2 or 3 meetings. It seems like test is quite challenging in terms of integrating chiplets, which were done with different flows, and how do you actually do it, right? Seems like uh, it's a lot easier when it's a single monolithic die, or even when you have multiple dies that you have a full control of. And it gets really interesting when you have multiple dies and you don't have control over those, right? Um, this seems to be a very complicated topic. Um, and really, there's only few areas. Typically, IEEE sets these test standards, right? So I don't think we have intention to define a new standard per se, right? You don't want to get into that. The question is, what kind of supporting information you can provide in CDXML and Web35 level to support DFT flow, the integration of chiplets for DFT, right? What does that mean? Today, it seems to be fairly labor-intensive process with a lot of customization. And the question is there any piece of data that can be carried, that can be provided by the chiplet owner to the next level to kind of simplify that integration, right? Both in terms of integration and also, right, once we have the way to integrate things, we can do at least basic sanity checking, make sure nothing is incorrect, right, just at a very basic level. Let's see if Bala joins us again today. We can continue that discussion. Um, Mark, any update on the IEEE side of things for 3D blocks?
Uh, well, just the last meeting was last week, and there wasn't really much technical content to the meeting. It was more procedural. Um, One of the things they asked people to do in that meeting is within the next two within the time frame of the next two meetings, which is a month essentially, um, review the rest of the 3D Blocks document and send in any comments. And so, there's really three main sections of the document. There's a section describing the kind of core connectivity and stack concepts. And then, and there's been some review of that by now. And then there's a section on feasibility analysis where they go into how they attempt to support early thermal and power feasibility analysis. And then finally, there's a section, I forgot what they call it, but it's basically it's a description of design constraints that is meant to be used before a team has all the detailed design rules that would come from the different fabs or whatever that are supporting the effort. Um, and I think they just call it common design constraints. So they want people to review all those sections and provide comments within the next two meetings. And they also did say that they're targeting March of next year for being ready, um, in the sense that by then they want to have enough of a review, enough of an agreement on the document that it's ready to be handed off to a technical writer who can then write that document up following the IEEE requirements for format and things like that. So just FYI, that's a kind of a rough target that's being suggested.
Yeah, that kind of lines up with what I was thinking, that it's going to take at least 1 year to get this done.
Mhm.
Yeah. Okay, cool. So I know that TSMC had removed some of the examples from the initial document, right, due to various legal issues. Is there an intent that the IEEE group will produce their own examples of what a definition would look like? Basically, start from scratch based off of the document and contrive some example.
Right. I think that will be necessary. Yes. I think at one point in the work group there was a short discussion about that. That yes, they wanted to remove the TSMC specific examples, but that we'll need to have some sort of more generic examples added in order to make things more clear.
Okay. Yeah, I think that would be very helpful.
I agree. Okay.
Yeah.
So hey, before we get into the technical content for today, I have a question for you. You mentioned that there was some good presentation by Bala in the last two meetings, and I had to miss last time's meeting, so I'm wondering how can I access the recording? Where do I go to get recordings from the meetings so that I could
Um,
do that?
yeah, that's a topic that I'm working with you, trying to figure out what do we do. The way it used to work is up until late last year, I think somebody at OCP will automatically, well, not automatically, but they will go and so this what happens with recordings. Zoom will record uh, every meeting, and it will store it on the Zoom server,
Hmm.
and it will stay there for. After that, it's gone. So at those, I think there was an OCP person at OCP who would regularly go and take all the recordings and put them on the OCP wiki page. And that worked until apparently worked until late last year. So right now that flow doesn't exist. So I am trying to figure out with OCP exactly how do we handle that, right? And it looks like it's gonna fall on me to do that work, copy file, create a wiki page and copy the recordings, stage them, create links and all that stuff. And I'm kind of working to get to that. I will dig up the recording from last week and I'll post it on the Google Drive and I'll let you know.
Okay.
Right, I'll try to dig up the recordings as far back as I can go, and then I'll post them and let everybody know. Probably the easiest way right now is I'll post them on in a folder on a Google Drive, and then we'll have to figure out, right? Everybody will have to figure out which recording is for what and so on, right? Until the wiki page comes online.
Okay.
Yeah, sometimes things get in transition, so I didn't know about this change, so I think we may have lost some recordings, unfortunately, or maybe not. I'll check with OCP exactly what happened and where it is.
Okay. Yeah, thank you.
Yeah. Okay, so today the intent was to have a test discussion, but I don't see Bala or anybody else who can help us have a good test discussion. So obviously, we won't accomplish much talking about tests. What else do you guys want to talk about for today? And so, but by the way, I'm not sure when we joined and if you caught the discussion that we're having with Mark about the 3D blocks, and apparently they will be working on some examples as part of the 3D block standard. You were asking where do we get 3D blocks test cases? I think that would be one venue.
Yeah, so I was unfortunately I was not able to attend the last IEEE working group meeting, so that's what Mark was updating. I see. Thank you, Mark. Yeah.
Okay, you're welcome.
Yeah, and David, I've reached out to Puneet Gupta. He's a
Okay.
UCLA professor, and they're also involved along with Andrew Khan in all of these efforts, right? So their group is also looking at 3D blocks currently. So I have reached out to him. I haven't gotten a response from him, but I have mentioned to him the 9 o'clock meeting tomorrow, because we can think about kind of consolidating the effort if we have an opportunity, because they may also have some additional open access IPs that could be useful to us.
What do you mean open access IP?
Meaning, if anything other than the basic standard cells, if we need anything,
Okay.
mock-up for other IPs there.
Yeah. Okay. So yeah, a few expectations about tomorrow. Sigmund is traveling on a he won't attend. He's traveling on a I don't know what to call it, on an academic trip. Let me put it that way.
Okay. Okay.
So he won't join us tomorrow. But we can have that discussion and see how we approach that.
Right. Yeah. So if I hear back and get a confirmation, I'll let you know. So at least you call in at 9 a.m.
Yeah. Okay. Yeah. Yeah. Sounds good. 8 a.m. tomorrow probably is going to be interesting. 9 a.m. is going to be interesting. 10 a.m. meeting. I'm not sure if you guys are aware. 10 a.m. Meeting. Basically OCP has revived the POC workstream. That's a proof of concept workstream. I'm not sure if you're familiar with that. So these guys started probably 5 years ago. Their first iteration, right, before there were anybody had any idea what a chiplet is. Their first iteration was to develop a prototyping board, right, with the idea that you would take off-the-shelf chips, create a board that you can prototype with, for software development and so on. And what they created was a base board with 3 daughter cards. They had a NIC, they had FPGA, and they had a CPU. So that worked pretty well. And the intent at that time, actually that effort had started when I joined. The intent at that time was, okay, we developed these boards. Why don't we try to take these chips as bare dice and put them on a package and see what does that mean, right? Understanding that this is pretty much a SIP workflow, but still it's interesting to see how do you put these things together and what happens, right? Connectivity, how do you assemble it and so on. That effort didn't complete mainly due to lack of funding and availability of bare dice. So they recently revived it, and the thinking is you probably have heard some of the discussions around golden chiplet, right? How do we do interop, right? How do I know what works with what? And there is the business workstream is kind of looking around that from business workflow point of view. I think the system workstream, chiplet systems workstream, is looking a little bit from the system level point of view, and the POC workstream is looking more from the technical point of view, right? How do we actually get this done? It is, the way I see it is, it's pretty much the practical effort, right? If the CDX, if you think of CDX as as the theoretical effort about how we put chiplets together, right? Where we define standards and we define workflows. That POC workstream would be the practical effort where we actually take chiplet A, B and put it together and see what happens, right? It is very similar to what we are trying to do with our OCP design, and they were very interested in the work we are doing and how we are doing it, not naturally, right?
So sorry to interrupt. The end goal is to actually realize the hardware, so there will be a manufactured silicon as part of that effort.
The end goal would be when there is chiplets ready, right, to be able to enable that interop between chiplets, right? Putting chiplets together and hopefully actually creating a substrate. Right, it would not be silicon, but it would be a packaged parts. Right. The idea is, how do we do prototyping with chiplets? Right. That's the very difficult problem right now. Right. Some companies do offer it, but probably you have to start it quite expensive. Right. Just the manufacturing part, not considering the effort to actually to design it. So kind of the prototyping piece, right? How do you even know that even if you have 2 chiplets with UCE or BO or similar interfaces, how do you know that they work, right? PCIe kind of solved that problem, mostly, right? Even with PCIe, if you get 2 chips from 2 different vendors, you still don't know whether they're going to work or not, right? But that's a lot simpler problem. In chiplets, it gets a little bit more complicated. So it's the whole idea about quick prototyping and verification. Right, because right now everybody is developing chiplets in isolation, and it's not clear if you have a chiplet from vendor A and vendor B, would they even work together, right? clearly they should, but what does it mean that they actually work together and do what you expect them to do? So that's a topic that's being tackled in many different work streams. The business work stream was proposing a marketplace with system C models, where right, it's a business workflow proposal that has many technical questions that need to be answered, mostly around how, right? Because just getting through system C models doesn't make them automatically work together, right? How do you make them work together is the next topic, right? So just wanted to give you a preview, since we have time, about all the efforts which are going on at OCP. So quite interesting stuff. Our effort in the design meeting is very, very relevant, right? Because we are actually working on the how to connect these things together, right? And we are trying to discover the actual gaps, right? And my comment to the business work stream was that our immediate gap is that we don't have system C models for everything, right? Not only closed source, but even open source. Some of those things don't exist, right? If you take RISC-V, for example, I don't think there's a transaction level system C model for that. So, and even if there was, right, I'm assuming somebody will have to write the C code for the RISC-V to actually make it do something, so you can see the transactions, right? So something happens. And so there's a lot of hows around this that are very, very interesting. So I don't know if you guys have any thoughts around that. But anyway, if you're curious, the business work stream is one place to attend. The other one is the Chiplet systems work stream.
Right. So David, can you help us guide to, it's 10 o'clock you said, right? How do I attend that?
Okay. So let me, give me a second, I'll find a link to this.
In the chat, yes, please. Yeah.
Yeah. How do I know about this? Okay. I think they moved even that part. I'm trying to see. Okay, here is. I'm gonna post. Let me post the link, and then I will show you what the page looks like. So this is the Open Chiplet Economy wiki page. And if you see meeting schedule and polling, this is the main OCE meeting. And here is the PLC workstream. I don't think this is Tuesday. This is okay. What was the calendar? Okay, here this is actually the this link here, the Open Chiplet Economy calendar, which will give you links to all the meetings. There is the 8 a.m. Here's the Chiplet POC. Why is the normal business meeting nothing here? I don't know. Bunch of wires. This is the Chiplet systems workstream at Wednesdays at 11. This is the die-to-die. There is the modularity work stream that is also not used. So things are a little bit in flight. Here's a business work group. They actually have their own wiki. No, this is the Google Drive. Chiplet systems work group. Okay, here's the wiki page. Yep. Let's see if there's anything in here. As I mentioned, right, on that question earlier on. Oh, this is actually a better view. Here's the modularity. Here's that's the spreadsheet. So follow this server project website.
OCP website here. Okay, and it's in
Yes,
the get
this
involved.
one. Yeah, we are OC is under the server project.
Yeah.
Right. OCP is split up in different things at the high level, different projects. And server is one of the projects under Open Compute, directly under Open Compute. And OC is under that, and then CDX comes in under that.
And you're referring to the open chiplet economy because the calendar OC business work stream call, right?
Yes.
I see. Yeah, 9
Yeah,
a.m.
this one, 9 a.m. Yeah, business work stream, folks.
Okay.
Okay.
Yep.
So
Thank you.
just quick update on what's happening. So Pratyush, next 2 weeks, I would depend on you to run the CDX meeting, if that's okay.
That's fine. Yeah.
Okay.
Yeah. And in your absence, John Chaka had, in the last instance, presented SI related, all the SI parameters that we need to
Yes.
include in our. He mentioned that he had included it in the document that we have for SI workflow. I haven't checked that though.
Let me take a look. Sorry, not this file. Give me a moment. VDK, SFPI. No, this is for my minutes. I don't see it. Let me touch base with John and
Okay, I'll
see,
ping him.
see
Okay.
where it's actually ended. This is a copy that Tom created. This is the same one. I'll actually delete that copy so that we are not doesn't confuse us. Okay. Yeah, let me also touch base with John and see what where he posted that stuff.
Well, yeah, this is helpful that you're sharing what you shared. It helps us to see how to get around.
Yeah. Yeah, this even I actually knew how to get around, and then things changed. So what you saw in the beginning is discovering don't know how to get around. So I apologize if it took a little bit of that. Yeah. Again, keep in mind that we're all volunteers at OCP. So we do a volunteer level kind of quality is what I'm trying to say. Apologize if there's calls here and there. Okay. What else is on your minds? Okay, if nothing else, then we'll circle back tomorrow at what is it? The government design meeting at 9 Pacific, and talk a little bit about the examples and so on.
Yeah.
Okay, all right, everyone.
Thank
That's
you.
it for today. You guys have a good one.
Yeah, thank you.
Thank you, you too. Bye.
Bye.
Thank you.